of structural isomers. In that first, position isomers. What are position isomers? Two or more molecules which have same molecular formula but different position of substituent, functional group, double bond or triple bond. Molecular formula same, but those molecules are differ by position of substituent or functional group or double bond or triple bond. Position different. Such isomers are called position isomers. Molecular formula same, position different. Position isomers are also called as regioisomers. Regioisomers. Position isomers example. First example, C4 or otherwise C3H7Cl. C3H7Cl. So see this molecular with this molecular formula, two molecules possible. This is one and CH3, CH here Cl and CH3. Verify once. Both molecules have 3 carbon atom, 1, 2, 3, 1, 2, 3, 1 chlorine atom, and hydrogen atoms are 4 plus 3, 7 and 6 plus 1, 7. Molecular formula same, but position of substituent different. This is 1 chloropropane, and this is what? 2 chloropropane. 1 chloropropane and 2 chloropropane are position isomers. 1 chloropropane, 2 chloropropane. Next example, if you see C3H8O. With C3H8O molecule, so I am writing two molecules with different position of functional group. CH3, CH2, CH2OH is one molecule and other is CH3, CHOH and CH3. This is another molecule. Here functional group, position of functional group on first carbon, propane, functional group position different. Prop plus An plus 1 ol, and here prop plus An plus 2 ol. Prop plus An plus 2 ol. Propane 1 ol, propane 2 ol are differ by position of functional group. Okay, these two are isomers. Here substituent position different, here functional group position is different. Next, if you see third one, C4H8. With this molecular formula, I can write two position isomers. One is CH2 double bond CH, single bond CH2, single bond CH3. This is one molecule, and I am writing another molecule with same molecular formula, CH3, CH double bond CH, single bond CH3. So this is what? but1ene, and this is what? but2ene. but1ene, but2ene are what? Position isomers. So position of triple bond is different. Thus we write position isomers. Okay. Now a question on position and chain isomers. Write possible chain isomers for possible structural isomers. Structural, that means position and chain isomer. Possible chain and position isomers. Chain and position isomers for C4H9Cl for this molecule. Stop. Right? 4 chain and position isomers are possible. They are first one. So first write up to here. Right. For this chain and position isomers, first I am writing CH3, CH2, CH2Cl. This is one. Next I am taking substituent at second carbon. here this is second possibility with N-butane. So for butyl group, you know, for butyl group how many chain isomers are possible? 4. With 4 chain isomers, N-butane for 2, isobutane. For isobutane, this is isobutane. So for N-butane, 2 types of hydrogen. Write possible chain isomers for this one whenever the type of question asked. Take for butane. So if you take butane, here CH3 and CH2, this is butane, N-butane, and here isobutane. For N-butane, how many types of hydrogens are possible? For N-butane, 2 types of hydrogen possible, AA type, BB type. So if you remove A type of hydrogen, you get one type of chain isomer. Here also same. If you remove B type of hydrogen, then B type of hydrogen replaced by chlorine. 2 types of isomers are possible, A type 2, B type 2. So 2 chain isomers possible. For isobutane, there are 2 types of hydrogen. These all are one type, A type of hydrogen, and this is B type of hydrogen. First to remove A type of hydrogen, any one A type of hydrogen, and take chlorine. Now remove B type of hydrogen, take chlorine. Thus how many chain isomers and position isomers possible? Total 4. So if you take this is A molecule, and this is B molecule, this is C molecule, and this is D molecule. What are A and B? A and B are, so in take carbon skeleton 1 2 3 4 1 2 3 4, that means they are not chain isomers. Okay, so between chain and position, RTF MCP, so C always dominated than positions. First verify for chain isomer. If chain isomer is not possible, then verify for position isomer. Here 1 2 3 4 carbon atom, this is also 4 carbon atom skeleton. So carbon skeleton same, that means they are not chain isomers. And verify for position. On first carbon chlorine, second carbon chlorine. So 1 and 2 become position isomers. 1 and 2 become position isomers. And if you verify for C and D, what are C and D? C is on C, parent chain contain 3 carbon atom, parent chain contain 3 carbon atom. So they are not chain isomers. Then verify for position isomerism. Chlorine at which position? Carbon skeleton same. If you take up to here, carbon skeleton same or not? CH, these 4 up to here, carbon skeleton same. Position of this is also carbon skeleton same. Only they are differ by position of chlorine. So they are definitely what? Position isomers. CD are also position isomers. If you see A and C are A and D, B and C, B and D, they become what? So if you see A and C, in A parent chain contain 4 carbon atom, in B parent chain contain 3 carbon atom, chain different. So they are what? Chain isomers. If carbon chain is different, parent chain is different, they are what? Chain isomers. If parent chain is different, they are chain isomers. First verify for chain. So if you see A and D, in A 4 carbon atoms in parent chain, B 3 carbon atoms in parent chain. So chain different, chain isomer. In B and C, parent chain with 4 carbon atom, parent chain with 3 carbon atom, so they are chain isomers. In B and D, parent chain with 4 carbon atom, parent chain with 3 carbon atom, they are what? Chain isomers. Thus, first we have to verify for chain isomerism. If chain isomerism not possible, then verify for position isomerism. Thus, they are relative. Okay. Next, ring chain isomers. Molecules which have same molecular formula, but one molecule has open chain structure while other molecule has closed chain structure. One has open chain, other has closed chain. One has open chain, other has cyclic structure. Such isomers are called ring chain isomers. One is ring, other is open chain. Okay. Next, see example for ring chain isomerism, C3H6. With C3H6, I can write two molecule. One has open chain structure, alkene, and other has cyclic structure, CH2, and here CH2, CH2. So 3 carbon atoms in each and 6 hydrogen atom. That means one is alkene and other is cycloalkane. Alkene and cycloalkanes are example. So this is what propene and cyclopropane. Propene and cyclopropane are example. Okay, or if you take this is example 1. If you take C4H6 formula. With C4H6 also I can write 2. CH3, CH3, C triple bond C, CH3. Number of carbon atoms are 4, hydrogen atoms are 6. With this molecular formula I can write like this. Count number of carbon atoms 4, number of hydrogen atoms are 6. One has open chain structure, other has cyclic structure. That means alkyne and alkyne, this is cycloalkene, double bond present in cyclic ring, cycloalkene. Propine, 4 carbon atoms, so butane, but plus 2ine, butane, and cyclobutene, these two also ring chain isomers. We have to verify one thing only. One has open chain, other has cyclic structure, but molecular formula same. Such isomers are called ring chain isomers. To understand the concept of structural isomerism, there is a small topic, double bond equivalence. Double bond equivalence helps us to calculate number of structural isomers possible with given molecular formula. Okay, so take this one. Next I will give double bond equivalence concept. Next, concept of double bond equivalence. What is the double bond equivalence? It is the number of double bonds or its equivalents possible with given molecular formula. Double bonds are its equivalents possible with given molecular formula. So what is the formula to calculate double bond equivalence? Double bond equivalence is equals to number of carbon atoms minus number of hydrogen atoms by 2 plus number of nitrogen atoms by 2 minus 1. This is formula to calculate double bond equivalence. So with this formula we calculate double bond equivalence. What is double bond? In between 2 carbon atoms there is double bond, simply. What is the double bond equivalence? One double bond is equivalent to one double bond is equivalent. One double bond is equivalent to one ring, one cyclic structure. Two double bonds are equivalent to two rings. Two rings that are equivalent to one triple bond. The double bonds or maybe equivalents of double bonds can be calculated by using this formula. This is important formula, helpful to determine number of possible structural isomers. Okay, first example I am taking. Calculate number of possible double bond equivalents with example 1, C3H6. How many double bond equivalents are possible? Or if question is like this, write possible structural isomers, write possible structural isomers with C3H6 molecular formula. C3H6 molecular formula. Then what we need to do? We need to calculate number of double bond equivalents. Double bond equivalence is equal to how many carbon atom? 3 carbon atom minus number of hydrogen atoms are 6. 6 by 2. Number of nitrogens are absent plus 1. 3 minus 6 by 2, 3. 3 minus 3 plus 1. That is equal to 1, 1. So double bond equivalence is equal to 1 double bond equivalence is nothing but 1 double bond equivalence means 1 dB means dB is equal to 1 means 1 double bond or 1 ring is possible. 1 ring, not both. 1 double bond or 1 ring is possible. With 1 double bond I can write how many possible structures with this one. I can write only one double bond CH. I cannot change the position of double bond. If double bond put here, then also it become propene only. Here double bond, nothing difference, same. Okay, so only one structure. Next, with one ring also only one possible, that is CH2 Thus how many structural isomer? Therefore 2 structural isomers are possible. 2 structural isomers. They are ring chain isomers. Only 2 structural, not position, not chain. Ring chain isomers are possible. So next, in next example, C4H8. With C4H8, how many structural isomers are possible? With C4H8, try to calculate dB, double bond equivalence for C4H8. Calculate the possible structural isomers. Calculate the possible structural isomers for C4H8. See, dB double bond equivalence is equal to, calculate double bond equivalence. Double bond equivalence is equal to number of carbon atoms 4, number of hydrogen atoms 8 by 2, number of nitrogen atoms are absent plus 1. That is equal to 1. It means double bond equivalence 1 means 1 double bond or 1 ring is possible. 1 double bond or 1 ring is possible. Write isomers with 1 double bond. With 1 double bond, 1 dB, what we can write for C4H8? 1 is CH3, CH double bond, CH single bond, CH3. This is 1. And CH2 double bond, CH single bond, CH2 single bond, CH3. This is second one. 2 are possible with 1 double bond. By placing 1 double bond between carbon atom, you can write 2 formulas, 2 position isomers. Next, with 1 ring, C4H8. So take bond line formula, that is very simple and become fast. CH2, 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 CH2. 4 carbon atom, 8 hydrogen atom. Or This is third one. Next, fourth one with this one. CH3, CH. 1, 2, 3, 4 carbon atoms verified, 4 carbon atom. Hydrogen atom CH3 means 3, here CH means 1, 3 plus 1, 4, here 2, 8. Molecular formula same, C4H8 for both. 2 rings, 2 plus 2, total 4 structural isomers are possible. So with first set, second set become 1, 2, 3, 4. With 1, 2, 3 fours are ring chain isomers, and these two are what? Position isomers. Next, possible structural isomers for C4H6. So first we have to calculate DBE, double bond equivalence. Double bond equivalence is equal to number of carbon atoms 4 minus number of hydrogen atoms 6 by 2. Nitrogen atoms are absent, so leave it, plus 1. That is equal to what? 4 minus 3, that is 1. 1 plus 1 is equal to 2. Double bond equivalence 2 means there may be 2 double bonds possible with that molecular formula, or 2 rings are possible, or 1 double bond plus 1 ring possible, or 1 triple bond is possible. 1 triple bond. 2 double bonds is equal to 1 triple bond. So equivalence of 2 double bond is equal to 1 triple bond. Thus first C for 2 double bond. Molecular formula C4H6, 2 double bonds are possible. One is CH double bond, CH single bond, CH3. So double bond, 2 double bond. 2 double bond means CH2 double bond, CH single bond, CH double bond, CH2. This is one possible. Next, second is cumulative diene. Single bond CH3. This is next with 2 rings. With 2 rings, 4 carbon atoms with 2 rings, only one is possible, like this. Next, third one with 1, I will take 1 triple bond. With 1 triple bond, 2 are possible. CH triple bond C, CH2, CH3. This is 1. 4 carbon atoms with 6 hydrogen atom, or otherwise triple bond at middle carbon atom. This is possible. 2 are possible. Next, I will take 1 double bond with 1 ring. 1 double bond plus 1 ring. 1 double bond with 1 ring. First I will take a 4-membered ring. This one, molecular formula C4H6, it will become CH2, CH2, CH, CH, C4H6. Next, reduce number of size of the ring. 3 here, 4, reduce 1, it becomes 3 with double bond here. With 3 carbon atoms, cyclic chain, here also possible. This is 1. Next one is like this. Like this one. This is also possible, total. Next, how many structural isomers count? This is 1, 2, this 3, 4, 5, 6, 7, 8, 9. Therefore, 9 structural isomers are possible. 9 structural isomers possible. 9 structural isomers are possible. Take this. Next, write possible structural isomers for C3H6O. First, calculate double bond equivalence. Number of carbon atoms are 3. Number of hydrogen atom 6 by 2. Nitrogen atoms are absent, plus 1, that is equal to 3 minus 3, 0 plus 1, 1. Double bond equivalence 1 means, it means one double bond or one ring is possible. And also with one oxygen atom, how many types of functional groups possible? Aldehydes, aldo group possible, keto group possible, alcohol group possible, ether group possible. We have to verify in 4. One oxygen atom means in molecular formula one oxygen atom means alcohol, ether, aldehyde and ketones are possible. One oxygen atom means any one of these 4 possible. First I am taking aldehydes. So aldehydes with one double bond. Aldehyde. Aldehyde. CH3 and CH2, CHO. This is possible. With one ring, aldehyde is not possible. Ring with aldehyde not possible. Next, taking ketone. So ketone, CH3, double bond O, CH3, ketone. So only one ketone possible. Cyclic is possible, but formula become different. So here one double bond, one ring is not possible. Then it means DBE2. Cyclic chain means one ring means DBE1, double bond means DBE1, 1 plus 1, 2. DBE is not 2. If DBE2, cyclic ketones are possible. Next, third one, verify for alcohols. Alcohols with double bond possible, with ring possible. Alcohol with double bond. First, alcohol with double bond. How many double bonds? One double bond. Alcohol with one double bond, I can write like this: CH2 double bond CH2OH. This is one molecule. Okay. Next, shift double bond to here. CH3 single bond CH double bond CH single bond OH. This is possible. Next, third one, CH3C double bond CH2OH here. So carbon atoms count. In all these 3, carbon atoms are 3 only, and hydrogen atoms are 6, oxygen 1. That means with double bond this one possible. Next, with alcohols with one ring. Alcohol with one ring. First I am taking butanol. If you count number of carbon atoms, cyclopropanol. Only this one possible. Okay. 3 carbon atom with OH group. Only this one possible. One ring. Next, ethers. Fourth one, ethers. In ethers also first one double bond, 1 dB ether, that is CH2 double bond CHOCH3. This one double bond with ether, 3 carbon atom, 6 hydrogen atom. In ethers, second possibility, one ring. In all those four, aldehydes, ketones, alcohols, ethers, one double bond, one ring, one double bond, one ring, one double bond, one ring, one double bond, one ring are verified. So here one ring with ether. One ring with ether with how many carbon atom? 3 carbon atom. So 3 carbon atom, cyclic ether, this one possible, one. Next one is this one, second one is possible. Next, third one ether, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 only. Another ether is not possible. So in this way, how many structural isomers? One aldehyde, ketone is the second one, this is third one, this is fourth one, this is fifth one, sixth one, and the seventh one, eighth one, ninth one. Therefore, what we can write? 9 structural isomers possible. 9 structural isomers possible. 9 structural isomers possible. Okay. Take this. Next and last question. See this question. Molecular formula of compound given C4H8O. Total number of cyclic alcohol. We have to take only cyclic alcohol X and cyclic ethers Y. X plus Y is equal to what? So first calculate dB double bond equivalence is equals to number of carbon atom with molecular formula 4 and number of hydrogen atom 8 by 2 plus 1, that is equal double bond equivalence is equal to 1. Double bond equivalence 1 means what are possible? 1 double bond or 1 ring is possible. 1 ring is possible. But in this only we have to take a ring. The cyclic alcohol, cyclic ethers are required. One ring with alcohol. Cyclic alcohols. Cyclic alcohols, how many possible? Then cyclic ethers. First I will see cyclic alcohols with 4 carbon atom. 4 carbon atom cyclic alcohol. This is one. 4 carbon atom. Molecular formula verify. That will match. Next here. OH group here and methyl group here, 1, 2, 3, 4 carbon atom. Otherwise, we can write like this also. Both OH and methyl group present on same carbon. This is also possible. Cyclic. Next, any other? Yes, other is OH group present on branch. This one is also possible. 1, 2, 3, 4 carbon atom. Okay. Cyclic alcohols, how many possible? 4 possible. Any more? Okay. Cyclic alcohols are cyclic ethers. Cyclic ethers with 4 carbon atom. I am taking this is 1. Then reduce ring size to 4. This one, take a branch here or take branch here, that will become one more isomer. And reduce ring size again, take 3. Ring size 3. Ring size 4 one branch, ring size 2 2 branches. Or take 2 branches here, like this, or take branch like this. That is one more possibility. Next, or take ether group on branch, ether group on branch. This will become 1. Count number of isomers in alcohols 1, 2, 3, 4, 5, 6, 7, 8, 9, N 11. Total 11. Total 11 structural isomers. Total 11 structural isomers. 11. Total 11. Total 11. X is equal to cyclic alcohols are 4. Cyclic ethers are Y is equal to cyclic ethers are Y. Cyclic ethers are 3, 3, 7. Y is equal to 7. Total 11. Okay. So hope you understood well. Thank you.